Aurel Persu Streamliner from 1922 is one of those cars that makes you pause for a second and wonder if you're looking at something from the past or something that somehow slipped here from the future. At a time when most cars looked like boxy carriages without horses, with flat panels and exposed wheels, this thing appeared looking like a water drop on wheels. And the most interesting part is that it wasn't built just to look unusual. It was a serious engineering project that ended up being decades ahead of its time. Aurel Persu was a Romanian engineer who studied and worked in Germany. At some point, he noticed something that most people in the early 1920s simply ignored. Cars were wasting a lot of energy fighting air resistance. Today, that sounds obvious, but back then, it really wasn't. Cars were designed based on practicality and tradition. Flat surfaces, sharp edges, exposed wheels. Aerodynamics wasn't part of the conversation yet. Persu, however, looked at it differently. He started studying airflow and natural shapes and came to a simple but brilliant conclusion. The most efficient shape for moving through air is a water droplet. Not a box, not a rectangle, a smooth, tapering form that allows air to flow around it with minimal resistance. And instead of just keeping that idea on paper, he decided to build an actual car based on it. Work on the car began in Germany around 1922 to 1923. This wasn't a big corporate project with massive funding. It was more of a personal engineering vision, but executed with serious precision and intent. The body of the car is its defining feature. It's fully streamlined with no abrupt transitions. The front still somewhat resembles cars of that era, but as you move toward the rear, the shape narrows dramatically into that signature teardrop tail. And that tail isn't there for style. It reduces turbulence behind the car, which is critical for lowering drag. One of the most striking elements is the way the wheels were treated. Unlike most cars of the time, where wheels stuck out and disrupted airflow, Persu fully integrated them into the body. This significantly improved how air moved around the car. Today, this might seem like common sense, but back then it was a radical idea. And here's the part that really stands out. The drag coefficient of this car is estimated to be around 0.22. To put that into perspective, that's on par with many modern vehicles. So you're looking at a machine built over a century ago that can match the aerodynamic efficiency of cars designed with computers and wind tunnels. That's honestly a bit wild. Under the hood, the car used a fairly modest engine for its time, a 4-cylinder inline unit produced by A-G Automobilbau in Berlin. The displacement was roughly between 1.4 and 1.5 liters, producing around 20 horsepower. Not exactly impressive by today's standards, but that's not the point here. Thanks to its aerodynamic efficiency, the car was able to reach speeds of about 50 miles per hour, which was quite respectable in the early 1920s. The transmission was a typical manual setup, and power was sent to the rear wheels. But this is where things get interesting again. The car didn't use a conventional differential. Normally, that would be a big problem because wheels need to rotate at different speeds when turning. Persu approached this challenge in a very unconventional way. The rear wheels were placed extremely close to each other, so close that they almost behaved like a single wheel. Because of that, the difference in rotational speed between them during a turn was minimal, making a differential almost unnecessary. It's one of those solutions that makes you think, wait, can you actually do that? But it worked. Steering was handled by the front wheels in a conventional manner, and the car was reportedly capable of taking corners at speeds up to around 37 miles per hour. For such an unusual layout, that's quite impressive. As for the suspension, it was fairly simple and typical for the time. A solid axle setup with leaf springs. No advanced independent systems, no electronics, just straightforward mechanical engineering. But thanks to the car's shape and weight distribution, it maintained decent stability on the road. The braking system, however, reminds you very quickly that this is still a product of the 1920s. Brakes were only fitted to the rear wheels. And if we're being honest, that sounds a little terrifying, especially considering the car's top speed. Driving this thing probably required not just skill, but a bit of foresight. You had to think ahead and start slowing down well before you actually needed to. Inside the car, the interior was very minimalistic. There was no luxury, no decorative elements, just the essentials. The cabin was enclosed, which was already a step forward compared to many open-top cars of that era. The driver sat relatively high with good visibility forward. The dashboard was simple, featuring basic instruments like a speedometer and a few essential indicators. The steering wheel was large and, of course, had no power assistance. Turning it likely required a decent amount of effort, especially at low speeds. Comfort wasn't really the focus here, but for its time, the car was practical enough. What makes this car even more fascinating is that it wasn't just a prototype that sat in a garage. Persu actually drove it extensively, covering over 74,000 miles. That's a huge number for such an experimental vehicle, and it proves that this wasn't just an idea, it was a functioning, usable machine. As for where the car is today, it has thankfully survived. The original Aurel Persu Streamliner is currently preserved in Bucharest, Romania, at the Dumitru Leonida Technical Museum. And that's honestly great, because machines like this often disappear over time, but this one remains as a physical piece of engineering history. Despite interest from major companies like Ford and General Motors, the car never went into mass production. Persu wasn't interested in simply selling the idea. He wanted it to be properly implemented. But manufacturers at the time weren't ready to take that risk. The design was just too unconventional, and the market wasn't prepared for something that different. And that's where this story becomes very familiar. An engineer creates something genuinely innovative, something that works and even outperforms expectations, but it's too far ahead of its time to be accepted. Looking at this car today still feels strange. It somehow manages to look both old and futuristic at the same time. The front feels somewhat traditional, but the rear, that smooth, narrowing tail, still looks like something out of a modern concept car. But when you look past the appearance and focus on the engineering, it becomes clear that nothing here is random. Every curve, every line has a purpose. This wasn't about making something weird, it was about making something efficient. In many ways, this was one of the first cars designed with a true scientific approach to aerodynamics. It showed that shape matters, that air resistance is not just a minor detail, but a key factor in performance and efficiency. And the most interesting part is that many of the ideas used here only became standard decades later. Streamlined bodies, integrated wheels, attention to airflow, all of that is normal today, but back then, it was revolutionary. If you think about it, if a modern car manufacturer revealed a concept with this exact shape today, people would probably call it bold, futuristic, maybe even visionary. And yet, this was done over 100 years ago, without computers, without simulations, just pure engineering intuition and determination. And honestly, there's something a bit funny about that. While many engineers of that era were building yet another box on wheels, Persu was already thinking several steps ahead. He didn't just follow the trend, he quietly went in a completely different direction. So, if you enjoyed this kind of story, unusual cars, forgotten engineering ideas, and machines that were way ahead of their time, make sure to subscribe to the channel. There's a lot more like this coming.